Ranok everybody, we continue talking about difference in statements and difference in result of which obtained with different statements. So today we talk about contacts, and this result is without non-linear contact. It's with linear contact, with bonded contact for all objects. So all 6 different type of contacts, with crank and base, with bolts and crank, with bolt and base, with pin and crank, all these connections, all these contacts are bonded. So it's a linear contact in term of axis. And we obtain a result for 3 phases that fixed for 10,000 of newtons. We obtain 0.57 millimeters. And if we apply contact between crank and base in non-linear variant of this contact, so for now it's frictional, not bonded. All other are bonded, and this one are frictional. And we obtain result 0.65 millimeters. So it's almost 20% of difference in result. If we go further and we change all type of contacts to frictional, so bolts and crank, bolts and base, pin and crank, crank and base, so all geometry, all geometry have non-linear contacts. We obtain 67, so it's less than 5% of difference in result on deformation. In stresses, we obtain 400 of megapascals maximum. We see that maximum is here. We don't understand where it is, but we'll talk about it later. 400 megapascals here, not here, and not here. If we change scale to original, we see that stress distribution behavior are much closer to original, and it's not very dependent on type of contacts for now for this task, but we see some difference, and we see that maximum with one contact is on the same place where we have maximum in original task with bonded contact. What difference in behavior we can see additionally? Here we see that our objects are glued one to each other, and it doesn't have any gap here, any deformation of bolts which are not corresponding to crank or base. If we take a look here on a task with one contact, we see some difference. We see that we have some gap here, and even here. But we almost doesn't have gap here for one contact. And our bolts are glued to crank, glued to base, so we have very small deformations here. It have a strange view here, but it's a reason that we project geometry of elements on a section plane, so it doesn't matter. And we see that here we have very big stresses, not the maximum, because maximum here, but big stresses here. And on the last variant, where we have the all contact, we see that we have maximum or on the bolt surface or on the hole of crank, which present here. We see difference in behavior. We see that gap here is present, and if we will change scale factor, we much better will see that we have gap here, and point of rotation of our crank are not here, are not here as on second variant, but here as on third variant. It's very small gap, but it present. In second variant, in reason of bolt which glued to both objects, rotation started here. And also we can see some difference in those places and those places for bolts, and for crank. So that show that contact can affect your simulation result very, very strongly. So it's it's very important to model your task with more physical contact if you need more physical behavior. It's longer because when you solve with nonlinear contact, you have number of calculations that you need to do for obtaining a result. But it's much more accurate. So, something like that. See you soon.